Hi guys, it's Miss Sandler, and today is Wednesday, and we are going to move on with talking about slope and linear equations. So first thing I want you to do is open to your table of contents, and what is the date? I think tomorrow's the 27th. And we are going to be learning about graphing linear equations. Graphing linear equations. And I believe, hopefully we're on page 10. Alright, so hopefully you received the note sheet. It's two pieces of paper stapled together. So this is going to go on to page 10 in your notebook. So go ahead and get that glued in. I'm going to get everything situated here, and then we will be ready to go. Alright, so let us begin. I'm going to zoom in a little bit here. Alright, so, sorry, it's bothering me that it's not straight. Okay, so, sorry, let me try and get this so that I'm content. Today we're going to look at graphing linear equations, and we know that a linear equation will give us, when we graph it, a line, hence the word linear. We know that something that is linear has a constant rate of change, and that constant rate of change is the same thing as slope. Okay, so hopefully that's refresher, you know that. Good. Alright, so what we're going to do is kind of like what we did, a few weeks ago with functions, when we had an equation and you had a table and you needed to substitute in a value for x to solve for y, to solve for your output. Okay, so if my equation is y equals 2x minus 1, I am going to, this is making me really annoyed, sorry. Just want it to be straight. I feel like I'm in front of you on the Elmo. If I have y equals 2x minus 1, and I'm substituting in negative 2 for x, I'm going to do y equals 2. Now I'm plugging in for x, negative 2 minus 1. And I know that when these are touching, it means multiplication. 2 times negative 2 is negative 4 minus 1. It's kind of like adding the opposite. So negative 4 plus negative 1, y equals negative 5. So my output, when I put in negative 2, I get out negative 5. Now I'm going to keep on going with my table. If you need room, feel free to write wherever you need it. Y equals 2 times negative 1 minus 1. 2 times negative 1 is negative 2 minus 1 is negative 3. I'm going to keep going. 0. 2 times 0 is 0. And 0 minus 1. Hopefully you can fill in this table before I do. So if you want to pause it, do it on your own and then see how you do. Substituting in when x is 1. So y equals 2 times 1 minus 1. 2 minus 1 is 1. And then 2 times 2, 4 minus 1 is 3. Alright, so hopefully you were able to get that on your own after you paused. So now what I'm going to do is I'm going to graph based on my input-output values. And all that it is an x and a y value. So this ordered pair is negative 2, comma negative 5. -2, -5. Now let's keep in mind I'm graphing a linear equation, so I know that this should end up being a straight line. So if it doesn't, something is wrong. -1, -3, 0, -1, 1, 1, and 2, 3. Oh shoot, I forgot a straight edge. Let's see if I can use this random postcard. This should work. I don't even know what this is. I think it's junk mail. So don't mind that. If I were to connect my dots, I'd be forming a straight line. Well, hopefully yours looks better than mine. Alright, so I want you to pause the video and go ahead and try this on your own for number 2. And I'm going to tell you, be careful with number 2 because you've got a negative x. So every time you write that equation, you want to put x in parentheses because it's really like -1x. Okay, so pause the video. I'm going to go through and explain it. And then when you are done, come back and watch and listen to see if you did it correctly, okay? Alright, so 1, -2. So y equals negative, and now x is -2 plus 3, and I know that a -2 is really a +2 plus 3, which is 5. -1, so y equals -1 plus 3, which is really like 1 plus 3 is 4. 0, well, -0, there isn't such a thing, so 0 plus 3. Y equals -1 plus 3, which is +2. And y equals -2 plus 3. -2 plus 3 is 1. Alright, so now I have my ordered pairs, my x, y's, and I am going to graph them. -2, 5. -1, 4. 0, 3. 1, 2, 2, 1. We take our straight edge, handy dandy straight edge, and we connect our dots. Now I know a line means that it's going to go on forever, so realistically I could extend on either side. Alright, so we just took an equation and we graphed it. So now we're going to try and make some observations. So hopefully if you've been paying attention since we've been doing functions and qualitative graphs, we talked about a few good vocabulary words. You might want to take a look back at your qualitative graphing notes, the one with that bathtub and when he went in and the water rose. So I want you to pause the video and see if you can answer these 3 questions at the bottom of your notes sheet, and then come back and listen and watch once you think you've answered them, okay? So, welcome back. In number 1, where does the line cross the y-axis? I know that the y-axis is going up and down, so I'm looking in number 1 to see where it is going through the y-axis. I'm actually going to just go over this. And I see right here is where it's going. Okay, so I'm going to actually circle it. So I see it's crossing the y-axis at -1. So at 0, -1, or just -1. Either one. Using the graph for number 1, calculate the slope using rise over run. Okay, so hopefully you went from point to point and you from left to right. So I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So +2 over +1 is my rise over run. Okay, so I have -1 and I have 2 over 1. This is the same thing as 2. Okay, so the last question says, is there a relationship between the equation in number 1 where the line crosses the y-axis and the slope? And if so, what is it? -1, +2. So looking at the equation, -1, +2. Okay, so maybe the relationship is, where does the line cross the y-axis? Okay, well, maybe this -1 is where it crosses the y-axis, and this 2 is the slope, but it says to see if it works for number 2, so I should check. Okay, so this is +3. It's crossing the y-axis at +3. And this is -x, which would be -1, which is like -1/1, which means down 1 over 1, down 1 over, down 1 over 1. Whoa. I think there might be a relationship. So I guess if you saw the same thing that I saw, it looks like the coefficient of x is the slope, rise over run, and the number being added or subtracted is where the line crosses the y-axis. Okay, bonus points. Who can remember what it's called when the line crosses the y-axis? The y... Oh, nice remembering. The y-intercept. I know you miss me. Alright, so we just made a really big discovery between the slope and the y-intercept, where our line crosses the y-axis. And hopefully you also kind of saw that as we were doing the graphing calculator activity. Alright, so go ahead and turn your notes. Okay, so this is called slope-intercept form. Okay, so anytime we have an equation that's y equals m, which is going to be representing something we just discovered, x plus, and this could be plus or minus, b, and we just figured out that b is also something. And it says here x and y represent the ordered pairs on the, and it's cut off. So ordered pairs on the graph. Alright, so hopefully you remember from the first page that the first number, the coefficient of x, is the slope, the rise over run. And b is where the line crosses the y